All right, so we're going to work on section 413, polynomial functions and multiplicity. And normally a lesson like this is a tough one, but we try to break it down in a way so that we didn't make it difficult, okay? We're going to try to give you certain situations that are easier instead of like starting you off with like a hard problem. We're going to kind of make it factored already. So like everything's going to be a little bit easier for us to do. But before we go into that, let me first talk to you guys about roots and how you find roots, okay? So, let's define them right here. So, roots. The word roots means solutions to an equation. Okay, so I guess you could even call it like the answer. Some people call it a zero. Okay, and we're actually going to talk about the word zero in a bit. But the word root, the word zero, the reason why they're called that is because of where you can find them. Okay, so let me give you an example. So I'm just going to draw a real quick small graph here, nothing major. I'm not going to give you an actual definition for the graph or anything like that. We're just gonna draw it. Sorry about that. We're gonna draw it kind of like a cubic function. All right, so something like that. So let's say I draw something like that. I'm gonna kind of zoom in just a bit so you can see a little better. So when we talk about roots, okay, the solutions of an equation, you can find them on a graph. It's pretty easy to find roots on a graph because remember we call them zeros as well. Now what does that mean? If you look, I'm going to kind of highlight where it crosses the x-axis. Okay, let me label those points for us just so we can see what those points are. So the first point on the left side, that's a -3, 0. This point here is 0, 0. The last point is 4, 0. The reason why we call roots zeros as well is because notice the y value for all three of them. So whenever you say, they tell you what are the zeros of the function, what they're saying is if y equals 0, what's the x value? So my zeros would be -3, 0, and 4, right? It would be these numbers right here. The x values, -3, 0, and 4. So these would be my zeros. Does that make sense? So if I give you a picture, you guys should be able to tell me what the answers are for that equation by just looking to see where it crosses the x-axis. That's all. Okay? On your homework, I think there's 1, 2, 3, 4, 5. Yeah, there's like 5 questions like that. Okay? Where they're going to say, what are the zeros to this graph? And they're going to show you a picture. All you have to do is look to see where does it cross the x-axis. Okay? Heck, there's even a picture that kind of looks like this. I'm going to draw another little graph for you guys. But let me do the following first. So I'm going to show you a graph of what some of the problems might look like on your homework. So they're going to give you a picture like that. I'm just going to mark some tick marks. Now all of these count for 1, okay? So all of these count for 1. And then they're going to show you kind of like a graph that's going to look similar to this. Just like that. Like it's going to be really weird. Like they don't even show you the whole graph. They just show you like a piece of it, right? And I'm going to kind of write down your numbers here. So 1, 2, 3, 4, 1, 2, 3. Okay. So I'll zoom in a bit just so you can see it a little bit better. Here's -1, -2, -3, -4. So there's like, I think 3 questions like this in your homework where they're going to say, maybe they're going to ask you, how many zeros does it have? Not what are the answers, but how many answers? How many roots? How many zeros does it have? So how many would you say? How many times does it cross the x-axis? 3 times, right? So if they were to ask you, for part A, how many zeros then you would say 3, because it crosses 3 times, right? Now if they ask you what are the zeros, or maybe to find the zeros, now they're asking you to tell them the numbers where it occurs. So where does that happen? X equal to what? -2. Where else? 1. Where else? 3. Anywhere else? Do you see any other places where it crosses the x-axis? No, just 3 places, right? So here you go. So is that hard to do? If they give you a picture, all you got to do is kind of look at it and say, here are my answers, right? Where it crosses the x-axis. Remember, they're called zeros because if I were to list the points, so I'll do that really quick. This is -2, 0, 1, 0, 3, 0. They call them zeros because the y value is always a 0. So we call them zeros, okay? Whenever the y value is 0, you're on the x-axis. So that's why they call them roots, okay? Because they're rooted on the axis, okay? Or you could just call them answers, right? Solutions, answers, roots, zeros, they're all the same meaning. So any questions on how to do these types of problems? So like I said, it's about like 4 or 5 problems very much like this, okay? There's also going to be problems on your homework that are going to look kind of like this. So let me just zoom out properly here. So I guess I could call this example 1 if you guys don't mind. I'm just going to write example number 1 here for you guys. Okay. So example 2, you're going to get some problems on your homework that are going to look similar to this. So let me draw another little graph. Just a small one, nothing too big. Okay, something small. Because this one's not really going to matter where it crosses or anything like that. The picture is what really matters. And let's see if you guys can remember something from what we did yesterday, okay? So what if I give you a graph that looks like that? Again, you guys don't draw it exactly like mine. All that matters is the shape of it. Draw however you want. Just make sure it goes up, down, and up, okay? The question they're going to ask us to do is to classify this function, okay? What that means is it a linear function, quadratic, cubic, quartic, quintic, okay? They're going to ask us, classify the function. In other words, what is its degree for this picture? What would be the degree to the equation for that picture? Now I'm going to give you a couple seconds. Think about this. How could you figure out the degree of the equation that would give you that picture? So think about it real quick. I'll give you like 15, 20 seconds. Just think about it. It does have to do with what we learned yesterday. Does anybody have an idea how we could figure that out, the degree? So yesterday we learned about the number of terms that a function has, right? And we learned that if the degree is 8, how many terms does it have? 7. One less, right? How many turns does this graph have? So it's going up and then it goes down. That's 1 turn, yep. Then up, that's 2 turns. So if it turns twice, then what power must it have been? Third power, right? Because 3 minus 1 is 2. This is a cubic. Okay? Because, I'm going to put right here, because it has 2 turns. Okay? If it has 2 turns, that means 1 more would be its power. Right? If it turned 5 times, that means it would be a 6th degree. If it turns 1 time, that means it would be a 2nd degree. Right? It's always 1 more than the number of turns. Okay? So there's going to be some questions like that on your homework. They're going to say, hey, can you classify it? Is this a linear, quadratic, quartic, cubic? Like, what is it? And you're going to see a picture. Count how many times it changes directions. Okay? So again, it starts going up. That doesn't count as a change in direction because that's the way it started. But then it goes down. So that's 1 turn right there. And then it goes back up. That's 2 turns. So add 1, that gives you the degree. Okay? So if you know the degree, you subtract 1 to figure out the number of turns. If you know the number of turns, just add 1. That's going to give you the degree. Okay? So I'm just looking at something here from your homework. But yeah, so that's what you're going to have to do for those types of questions. All right, so we've talked about what roots are, okay, how they look like on a graph, right? That's like example 1, right? What they look like on a graph. We talked about ways you can figure out how many they have and where to identify them, right? We also talked about based on a picture, can you classify a function? Can you tell them if it's cubic, quartic, right? Stuff like that. You got to figure out how many turns it has and then just add 1, okay? That's going to tell you the degree. Now we're going to get into like the meat of this lesson, okay? And here I can actually do some problems from your homework. So, example number 3. So we'll see if we can try to get 2 problems done here. So, what are the zeros? Now remember, zeros means solutions, the answers, the roots, right? So the solutions. What are the zeros of the polynomials? Okay, so let me give you the first problem here. So y is equal to 3 times x plus 4 times x plus 1 times x minus 3. Now notice, remember how I told you we made this easier for you guys, right? Because you're not going into trig right now. You guys are in algebra 2, so we don't need to give you guys trig level difficulty problems, right? So what we did is we got problems and we factored them out for you guys to make them a little bit easier as we start learning this. Okay, just so that you guys can understand the content of it, not so much get confused with factoring. We're not going to worry about that right now. But they tell us, what are the zeros? Now, it's already factored for you, okay? Now, this is supposed to be easy because you guys are, like, obviously supposed to remember everything you learned in Algebra 1, right? But in case you forgot, maybe, right? There was this property that you guys learned in Algebra 1 called the zero product property. So zero product property. Does anybody remember? Does that sound familiar to anybody? The zero product property? It may be something we learned in Algebra 1, but trust me, you use it forever. Okay? The zero product property basically said this. If you had, say, A times B times C, and it was equal to 0. Okay? If you have this, then either A equals 0, B equals 0, or C equals 0. In other words, get each little piece and set it equal to 0, and then you solve. Okay? So why is that important? Notice over here, they want us to find the zeros. In other words, solve these things. Okay? They want me to rewrite it like this. 3 times x plus 4 times x plus 1 times x minus 3 equals 0. Right? Find the zeros. What makes it a y value of 0? Okay? And all I have to do is the following. Each little piece, how many things are being multiplied on the left side? How many terms? We got the 3, that's 1. We got the x plus 4, that's 2. We got the x plus 1 and the x minus 3. We got 4 things equal to 0, right? So this is what you're going to do. 3 equals 0. X plus 4 equals 0. X plus 1 equals 0. X minus 3 equals 0. Put this in a box over here. Give me a second. I'm just going to move these a little bit to the right. All right, here we go. Now, can 3 be equal to 0? I mean, is 3 equal to 0? No, right? So that's not true. What's my answer for x plus 4 equals 0? What's x equal to? Like, what do I have to do to both sides? All right, so subtract 4 on both sides. So x is negative 4. What do I do on both sides for the x plus 1 equals 0? All right, so subtract 1. I get x equals negative 1. And for the last one, what do I do to both sides? Add 3. Notice these are pretty easy to solve, right? These are called one-step equations. So my answers are x equals negative 4, negative 1, and 3. So, I mean, hopefully you guys see this isn't that hard to do. Okay, it's not that hard to do. We already are going to pre-factor them for you. Okay, let me look for one more that we can do really quick, and then we'll move on to the ones that have multiplicity. I'm just checking real quick. So, all right. So let's try one like this. Y equals, we'll do x minus 3, x plus 4, x minus 5. And I want you to find the zeros for this. Okay? So you're going to set all of those factors, x minus 3, x plus 4, x minus 5, and you're going to set them equal to 0. And you're going to use the zero product property, okay, which basically says, hey, if you got a bunch of stuff multiplied together and it's equal to 0, set each little piece equal to 0. So x minus 3 is 0. X plus 4 is 0. X minus 5 is 0. Again, this is an Algebra 1 property, okay? This is from 2 years ago. So it allows us to break up all these products and separate them into individual problems, okay? So now if we go ahead and solve, we'll add 3 on both sides for this one. So x equal to 3. Over here we'll subtract 4. So x equals negative 4. And over here we're going to add 5. So x equals to 5. Again, this is old school stuff that you guys have done many times before, just solving a single step. So I'm not too worried about that. So my answers are negative 4, 3, and 5. And that's going to be my solution to this problem. So hopefully that's not too bad, right? Like I said, they're already pre-factored for us, so we're not having to do that really hard step where they give us a fourth power or a third power equation, and we're going to have to figure stuff out ourselves. Like, thank goodness we don't have to do that, okay? They're making it easier on us. Now, how can they complicate this a little bit more? So, multiplicity, okay? It's not that it's going to be way different from what we're doing, but I'm going to teach it to you guys through example, okay? So, example number 4. What are the zeros? Same instructions as the other ones, but you're going to notice something a little different in these problems. It's not going to be super obvious, but it's also not super hard to spot, okay? Can you tell me what's different from these problems, the one I just wrote, and the ones up on top, like between A and B? Do you see something that's just a little different that the other ones didn't have? The square, right? The power, all of a sudden there's a power. If you have a power on the outside, we call that a multiplicity, okay? We call that a multiplicity. Okay, so we're just going to put power on the expression. So you're going to see a power on the expression. If it's even, meaning that if it's an even number, like a 2, a 4, a 6, an 8, just know on a graph, we're going to say it bounces. And I'm going to show you what it looks like on a graph, okay? We're going to say it bounces, okay? If it's an odd power, then it goes through. It crosses the x-axis, okay? So through the x-axis. Okay, so that's important for when they start giving us pictures and they're going to say, oh, what's the multiplicity of this number? What about this number? So you're going to look to see, is it bouncing off of it or is it going through it, right? But we won't worry so much about this right now. Multiplicity also means how many of that solution exists. So how many of that solution exists? In other words, right now you'll see what I'm talking about when we solve this problem that we have to do. Just curious. So let's go ahead and do this example really quick, so you can see that's not much different from what you're already doing. Okay, so don't get worried like, oh no, a whole new thing. It's the same thing, guys. If they want you to find the zeros, you're going to do this: x plus 1 times x minus 2 squared equals 0. Notice, same thing that we did before. And then you're going to get x plus 1 equal to 0, x minus 2 equal to 0. Now, if you're wondering, wait a minute, what happened to the square? The square doesn't matter when you're setting it equal to 0, but it does matter when you write your answer, and we'll talk about that in just a couple seconds. When I solve for the first one, I'm going to subtract 1. So x equals negative 1. If I solve for the x minus 2 one, I'm going to put 2, add 2 on both sides, so I get x equal to 2. Now, here's where that power comes into play. Here are my answers. Negative 1 and 2 multiplicity of 2. Okay? This power gives me that statement right there. So if the power was a 3, I would write multiplicity of 3. If the power was a 6, I would write multiplicity of 6. Okay? What does that mean? That means that the answer of 2 occurs twice. I know that sounds kind of weird, but the answer of 2 occurs twice within the problem. Okay? So if there was a power of 3, that means that the answer occurs 3 times within the problem. If there was a power of 6, that means that the answer occurs 6 times within the problem. So right now I'll kind of show you a picture if I really get a chance to do that. So Let's just do one more of these. And then let's see if I can get a picture. And I don't know if I'm going to be able to, but you guys should be able to tell in the picture what they look like, okay? But I hope I can get that in here. So if we solve this, x plus 4 to the third, x minus 2 equals 0, right? So remember, I'm not going to worry about that power right now. I'm just going to write x plus 4 equals 0, x minus 2 equals 0. And then go ahead and solve. So you'll subtract 4. You get x equals negative 4. And for the other one, you're going to add 2. And I get x equals to 2. Now, remember how that x plus 4 had that power of 3? Right there? So when I write my answer, I'm going to put negative 4. And what should I write? Because of that power of 3, what do I write? Multiplicity of 3. You can abbreviate it mult, M-U-L-T, of 3. And then your other answer will be 2. And there's your solution. So notice it's not hard to do multiplicity. It's just you got to mention it. You got to say, oh, this was a power of 4. Okay? So, if you guys could just bear with me, one more thing I can try to do within these last 2 minutes. If you don't want to write it down, that's fine. You can see it in your notes later. But just check this out really quick, okay? So just pay attention. Pay attention. Don't get distracted because it's going to be quick. So, okay, look at this graph. You guys see it passes right there and right there, correct? What are the two numbers where it crosses? Let me label it. 1, 2, 3, 4. All right, negative 3, and what was the other one? Positive 2. So I'm going to write this. X equals negative 3. Now you notice how I went right through the x-axis? Then perfect, no big deal. That's an odd multiplicity, okay? Odd multiplicity because it goes through. The answer at 2, you see how it bounces off? How like it's going this way and then it just like shoots back the other way? That's because it has an even multiplicity. So an even multiplicity on your graph, you're going to see it bounce like a trampoline. Either it bounces up or it bounces down, but it's going to bounce off the x-axis. If it's odd, it'll go through.